Okay, this is the last homework problem from set 1, and it says a ball is thrown vertically upward from a point 40 meters above the water. It hits the water 4 seconds after its release, and we're asked to determine V naught and determine the speed right before it hits the water. So important information from the problem description is it's released 40 meters above the water, and it hits the water 4 seconds after it's released. If we draw a picture, this is where the ball is released from, or the ball is released from. This is 40 meters above water. So our time it takes for the ball to go up, reach a top point, and come down is 4 seconds. When the ball hits the water, we know that we're going to call this x is equal to 0 meters, and we define our positive direction to be this way, our positive x, and our positive velocity to also be in this direction. Because we're dealing with something on Earth, we have the force of gravity, and gravity is going to act in this direction. So our A, since it opposes our positive x and our positive v, our A is going to be minus 9.81 meters per second squared. So if we write all the information we know, we have an initial x, xi, or x naught, is equal to 40 meters. A final x, xf, is equal to 0 meters. Our initial velocity is unknown. We're solving for that. Our final velocity is unknown. We're also going to be solving for that. And our time is 4 seconds. And the acceleration is 9.81 meters per second squared. If we look at the kinematic equations we know, we have these 3 equations. This is V naught. And we're going to look at what we're given in the problem and what these equations tell us. And we're going to figure out which part of the information we don't have and plug it into that equation. So if we look at this, we have a x initial and x final. We don't know V naught, which is part A, and we don't know VF. So VF I'm just going to call V, just to keep consistent with what I wrote down for my equations. And since we don't know that, we really can't use this equation yet. We can't use this equation yet either because they're both dependent on a final and initial velocity. So we have, for part A, we have this equation. If we plug in what we know, we have 0 is equal to 40 plus V naught times time, which is 4, plus 1/2 minus 9.81 times 4 squared. And if we solve for V naught, we're going to get V naught is equal to 9.62 meters per second. So we know our initial velocity is 9.62 meters per second, and this is at this time when the ball is thrown up. This is our V naught, and we're asked to determine the speed when it hits the water. So when it hits the water, it's the instant it hits the water, and it's right here. So now that we know our v naught, we want to determine the speed when it hits the water. So at 4 seconds. So if we use this equation, the first equation we get v is equal to 9.62 plus a minus 9.81 times 4. And when we do this, simplify this equation, we get minus 29.6 meters per second. So this is the answer to part B. And what this means, this minus sign, it means, since we've defined our positive velocity going in this direction right here, that the minus sign means the velocity is moving down in this direction. So it makes sense. Our answer makes sense.